Good afternoon. Welcome back. We have Shabab Saad with us to talk to us today about carbon fiber and his company, Carbomat. Shabab, welcome to the program. Please introduce yourself, your company, and give us a hint as to kind of what you guys do and why you do it.
Good afternoon, Kent. Thank you for inviting me to your interview. Excited and glad to be here. Shabab Saad here, CEO, co-founder of Carbomat. Carbomat is a young and growing startup in the Albertan startup ecosystem. We are producing carbon fibers, low cost and sustainable carbon fibers for multidisciplinary composite applications. The technology that we have developed is unique because of how we can reduce the production cost of carbon fibers by 60% and the associated greenhouse gas emissions by almost 50%. We're in this business. We are developing this technology because we have a hunger for reaching a net zero goal by 2030. Basically, that's what everyone's shooting for, and we're in the same game. So that's more or less in a nutshell of what we do. But yeah, excited to talk more and see where it goes.
So, how did you get into carbon fiber? I mean, to me, I hear the term, I think about a ski boat, I think about a hockey stick, I see pieces of it in expensive cars. How big is the marketplace is kind of one question. And then the precursor to that is why you and how did you end up wanting to play in this, what I would say is maybe a nebulous space for a lot of people?
Yeah, absolutely. So it all started, back in 2020 as part of a provincial-wide challenge known as Carbon Fiber Grand Challenge. So the government of Alberta has been, thinking about a program. I think it's almost, we call it a 6 to 7 year program, including 3 different phases. So the government of Alberta, Alberta Innovates, Stantec, the major oil and gas industries here in Alberta, they've all looked into this market space. So bitumen has a heavy fraction. We call it asphaltenes. Asphaltenes are, we call it a low-value waste byproduct, currently has no market value for any application. So they have been carefully, I think, looking into the opportunities of how we can utilize asphaltenes to produce value-added products. And it all boils down to a high-value product known as carbon fibers that could be produced out of these asphaltenes. So that's where, we come in as a team. At that time, we were part of the University of Calgary. So we start off with the first phase of this challenge in 2020. So we started merely with a small $50,000 grant for proof of concept. And that's when we started to understand, realize better the need for carbon fibers, the need for low-cost carbon fibers in the market, only because there are so many markets available right now who do not have access to low-cost sustainable carbon fibers. So that's how we all came into the game. And you talked about the precursor material. So it's basically oil sands asphaltenes. We have plenty of these asphaltenes right now in not only in Alberta. We have asphaltenes available all around the world. If you think about any oil sands processing unit or facility available in Middle East, some parts in Europe, and also in US, there are asphaltenes produced right now all over the world in different places. But since Alberta is one of the largest producers, we thought Alberta is the right place to start.
Okay. How big is the market for carbon fiber?
Right. Yeah, it's right now, the global demand for carbon fibers is roughly around 150,000 tons per year. So that is the global demand of carbon fibers. Still limited, still restricted, only because we do not have access to low-cost, sustainable carbon fibers. The carbon fibers that are produced right now are high-end carbon fibers produced specifically for applications in aerospace, in wind turbines, in pressurized vessels. So for high-end applications, that basically leaves out all the commodity grade markets like sports, recreation, marine, defense, construction, you name it. So they're all, all of these markets right now are struggling to afford carbon fibers. And that's one of the reasons why the global demand is still, kind of restricted. So we see that, so based on a market projection, we have seen all different kinds of market projections coming out from the major carbon fiber manufacturers in the world. And we see that as soon as we bring low-cost, sustainable carbon fibers to the table, we see that market to grow by fivefold. So that's more or less about the market. I see that there are a lot of opportunities how we can grow that market and how we can integrate Carbomat into that market and serve those underrepresented customers in the industry.
That's pretty wild. You think about the forefront of an industry that exists, but good for you for finding some technology, creating it, right? The science, if you will, to take it, but then allow it to increase. And I'm sure if the market grows by 5 times, that's probably still a snippet of what it can be, because when you get to a market of that size, not only does your production costs come down, there's other efficiencies, but demand magically grows too, because people now get to play with it in a much more cost-effective way. So when you think about carbon fiber in the marketplace, do a little dreaming with us. Where do you think all the places you could use it that the regular average Joe person hasn't even dreamed of yet that could make life better for us all?
So to answer that question, we recently completed a product analysis. We call it a product TA analysis, and that's completely guided by our customers that we have in the pipeline. You could make all different kinds of products, Kent. For example, it can be something very simple, such as for example, your battery casing. So if you think about structural batteries for electric vehicles right now, the battery casing could be made out of carbon fibers so that you can increase the efficiency of your batteries for those EV applications. Carbon fibers could be used for even your wallets. So there's a company, I think they're based out of Europe. You can check them out. They're called the Ridge. So Ridge is working on, I think they have it in the market right now, carbon fiber wallets. So providing more stiffness, more strength, lightweight wallets, also enhanced security because you have carbon fiber plates in it. It has some sort of security features. So people going back 10 years, for example, I don't think any of us realized or imagined using carbon fibers in wallets. Right now, carbon fibers could be used in phone cases, in your laptop screens. Carbon fibers could be used in drones, in marine applications like electric boats. Carbon fibers could be used in marine decks, marine yards. Carbon fibers could be used also in construction applications. We were recently talking to ZS2 Technologies based out of Calgary. They're very, very excited to see the potential of carbon fiber usage in construction applications for wallboards. You could use carbon fibers in automotive, and that has been a great topic of interest between Carbomat and our strategic partners, that how we can use carbon fibers more in general commodity grade automotives. Right now, they're only used for luxury grade automotives. There's so many applications. I can keep talking about it all day, but I think the sky's the limit here.
Truly, I think it is. I mean, you mentioned wallets. I think I have one on many years ago. My wife bought me a gift. I think it's called Z Clip. And one of the options on there is the carbon fiber clip. Super cool. But yes, yeah. I mean, in a crazy fun world. In this journey, as you're about to, so can you share with us where you're currently at in your pilot project? Does it mean that you're currently building a facility to build the carbon fiber?
You're right. So we have completed the gram scale prototypes. So we have been working on this technology for almost 4 years. Over the past 4 years, we have completed, demonstrated, consistent production using our gram scale prototype. So our prototype runs well, but we only produce a small quantity. So to accelerate that, we are almost near the end of designing the pilot. So the pilot plant is almost ready. The design is almost ready. We're working with a couple of vendors. The goal of this pilot project is to have that pilot plant ready in Calgary. So that's the goal. So we go from a gram scale production unit to a kilogram scale production unit. The target right now is 1 kilogram per day, with a minimum production capacity of 1 kilogram per week. So that's what we're doing right now. The pilot plant would be very beneficial to make a lot of carbon fibers so that we can start product development testing with our customers that we have in the pipeline.
Okay, back up. So I want to make sure we all heard this. So you said your early stage was to build 1 gram. How often?
Not 1 gram, around 30 grams per day.
So you want to get to 30 grams per day.
No, we have that already. That's in the prototype. Yeah.
Okay, so 30 grams per day, and you want to get to what?
1 kilogram per day. So
1
that's a
kg.
jump. That's a jump from a gram, a couple grams to a couple tens of grams to 1 kilogram.
Now, for those of us who really can't comprehend, what would it mean to produce 1 kilogram a day of carbon fiber? How much would that be? Because the whole point of carbon fiber is lightweight.
Mhm.
So how else, if I flattened it out, if that was a thing, how thin would it be? And how far could I spread it? Could I cover a hockey rink? Could I cover a football field? Would it be 1,000 square feet? How many, 1 kilogram, how thin, how much would it cover?
So you can ask me why 1 kilogram per day? Why not 1,000? Why not 100? Why not half? So maybe I can explain that. I can explain that first, and then I'll get to the second part of your.
You win. You answer the question. Go for it.
Yeah. So the first, then I'll get back to the second part. 1 kilogram per day is basically coming from feedbacks from our customers. So every time you want to develop a product, you want to initiate testing of different products using your carbon fibers, that is the minimum volume, that is the minimum quantity that you need to test a certain product or test different various products. So that's what, based on these discussions that we have been having with our customers over the past 2 years, we understand that it is extremely important that we take that production capacity to 1 kilogram per day. If you're producing a kilogram per day, we can ship out a kilogram every day to all of our customers, and that would be extremely valuable. That would be meaningful as we navigate our GTM strategies, our go-to-market strategies. And I think that's going to add a lot of value to what we're doing right now, because when you're developing a product, for us, the product is carbon fibers, right? So when you're developing a product, it is very important that you get feedback from your customers so that you can tailor the properties of your product, you can tailor the features of your product, so that you have that back and forth testing with your customer before they take our product and the final product to the market. So that's basically the reason behind that kilogram scale. And the second question is, how big is 1 kilogram? So carbon fibers are extremely light. If you talk about a single fiber, it is thinner than your hair. So it is approximately in the order of 7 to 8 microns. So that is the size of a carbon fiber. So a single carbon fiber, a single strand of carbon fiber would be difficult. It is difficult actually to see with naked eyes. So if we talk about a kilogram is a lot. The density is very low. I think roughly around 1.12 or 1.2 grams per cm cube. So you can now just imagine how much a kilogram would be. It would be very fluffy. It's probably going to take up your entire table or probably more. So that's in a nutshell, but yeah, of course, 1 kilogram is not going to cover a football field. It is not that much, but it is enough to make a product prototype. It is enough to initiate some product testing with our customers.
So you're saying, so it would it be a ball? Like, give me a visualization. You said it would kind of, or it would be enough to cover a kitchen table.
It's not going to be a ball. So carbon fiber has a density of, let's say, around 2 grams per cm cube, right? So if we
Yep.
quickly do the math, then we can figure out how much that would be. But it would not be a ball because our carbon fibers right now are chopped carbon fibers. So they are strands. They're short carbon fibers and they're strands. So if you can think about a flat sheet of thin material, that's how the carbon fibers look like. So for example, if you're making a phone case, for example, so I have a phone case over here. If you're making a phone case, then you're probably using a small quantity, probably 30 to 40% of carbon fiber in it, which is not really not even half a kilogram. So if you can think about a kilogram, I think a kilogram of fiber would probably take up your table that you have in front of you right now. But they're not fluffy, they're not curled, they're straight filaments, but chopped and short right now.
Absolutely phenomenal. So, like, when we use carbon fiber, it sounds like then we often would integrate it or marry it or blend it with other products. And is that your job, or is that then the job of the manufacturer? So it comes along, they buy it from you, and they will use carbon fiber as part of the recipe or one of the ingredients to build other things then?
You're right, absolutely. So as carbon fiber manufacturers, we're going to be supplying carbon fibers to our product developers. So basically the composite manufacturers. They're going to take the carbon fibers and they would integrate the carbon fibers in different products. So each product has its own manufacturing technique. For example, if you're manufacturing a part of a drone, for example, if you're manufacturing the wings of a drone, that would probably be a different manufacturing technology than manufacturing a battery casing or manufacturing the vehicle frame of your automotive. So each would be different, Kent, depending on the type of product you're making. But yes, the process in the value chain is where we supply carbon fibers to those composite manufacturers. They take our carbon fibers, they mix it up with some resins, they mix it up with some thermoplastics, and eventually you have a product. It could be molded, it could be 3D printed, it could be it could be any combination of manufacturing processes that they have expertise in.
Pretty impactful, important stuff. A lot of wisdom, a lot of knowledge, which also means there's probably been a few lessons along the way. When you look back at your time in this journey over the last 4 or 5 years, what is the greatest lesson, or what is the one thing that you now know that Shabab from 4 or 5 years ago should have known or would have been helpful to know on day one?
Oh, I think that's a long list, Kent. I feel like I need to get my head around and really think which ones are the best learnings that I've had over the past 4 or 5 years. But I feel like when you're leading a startup, when you're at the forefront of developing a technology that is competitive and has a great market, a wide market, a global market, uh, you're always on the go. There's no rest. You need to make sure that your business plans and your business strategies are effective. I had no idea how to make a business plan, right? I had no idea how to make a business strategy. So I feel like over the past 4 or 5 years, I have learned so much from all the mentors that I've worked with. So all the mentors that I've worked with as part of different programs, accelerator programs that I've been a part of, I think it's I would not be able to, be grateful because of the amount of mentorship and the amount of learning I've learned from them. And I think it's the business aspect, is the business side of it that's probably the most important. Back then I was a tech guy, right? So when you're a science guy, you're always thinking about, the results. You're thinking about experiments. You never think about beyond that. And what I have seen, and the way I have evolved over the past 4 or 5 years is, how I have been able to connect the dots between a technology and how that can be turned into a business, and eventually right now how that could be pushed towards commercialization. And I think that's the biggest lesson that I've had over the past couple of years, and it would have never been possible without the constant advice, mentorship that I've received from so many mentors. I don't think I can even name all of them in this interview.
Absolutely amazing, dude. Like, we're clearly running out of time. I think I have another gazillion questions. But I do want to say thank you for the vision, what you're doing, the hard work. Anything that helps us have, I guess for me, thank you, because I love entrepreneurship and I love what they do for the world, because it's the fundamentals of capitalism that makes our life better, because the supply and demand always balance out with what we put value in. And, whether it be lighter planes, better efficient cars, better manufacturing, whatever. And I think not too often in nowadays we get somebody in Calgary, in Alberta, doing something so unique. I mean, there isn't too much nowadays that's new. And so good on you for something new, doing it different. Love it. Please keep us informed, keep the story going, and keep learning. Can't wait for the rest of the story.
Thank you so much, Kent. I think it was a pleasure being here. I tried to share a snapshot of what we're doing right now, what we did in the past, my learnings, my takeaways from everything that I've done. There's a lot to do. We're still scaling up. We still have to hit the market. Lots of strategic partnerships to develop, both in the upscale and both in the upstream and the downstream side of the business. So very excited to see how this story unfolds, how a sustainable technology could be built in Alberta for the first time in the material science sector. There's not a lot of people working in advanced materials in Alberta. I think we're probably one of the few. So I'm very excited to see how the future unfolds. And yes, thank you once again for having me.
You're welcome. Have a great week.
All right, take care. Bye.